Welcome back to the course on Compiler Design Lab. In this video, we will be discussing your third experiment, which is to implement the epsilon closure of an NFA. So consider this NFA which has got three states, and each of these states accepts two symbols 1 and 0 and also the epsilon move. So in order to implement this, what you have to do is first your program has to ask how many states your NFA has. So what are how many states this has? It has got 3. And what are the states? Okay, what are the states that also your program should ask? So the states are A, B and C. Then it should ask what are the input symbols it is accepting. So it's accepting 3 input symbols. They are 1, 0 and E for epsilon. Okay, E denotes epsilon. Then it should ask what are the transitions. So what are the transitions for A, B and C when it gets a 0, when it gets a 1 and when it gets an E, what are the transitions. So to A, when you give 0, what happens? It goes to B. It also goes to C. Okay. Then when you give a 1, it remains in A. When you get an epsilon, it moves to B. Okay, at B when you give a 0, nothing will happen. Okay, you can just enter a hyphen or dash. Then for B, when you get a 1, it will remain in B itself. When you get an epsilon, you move to C. Then at C, when you get 0, you remain in C itself. When you get 1, you remain in C itself. This is your transition diagrams, transition table. Implementing epsilon closure is very simple. You read this, and what you are going to print, you will print that the epsilon closure of A is what? A, and then what? Whatever is belongs to the input E, right? So A comma B, and epsilon closure of B is what? Epsilon closure of B is B comma C. And what is the epsilon closure of C? Epsilon closure of C is C. Okay, this is how you have to implement. So basically you can use a structure to implement this, or you can even enter these things, transition table, all these details in a file, read from it. Okay, you can implement it in any way. So that's up to you. Thank you.